Welcome to the security track. Our talk will start, actually your talk, not our talk, your talk, Rob's talk, will start in about a couple minutes. So thanks everybody for coming. Again, you're in the privileged beluga room where you can watch belugas do beluga things.
Oh, I thought this was going to be really cool. You're pinch hitting my talk? That's awesome. I get to learn something cool.
I've seen a service mesh before. I've seen one.
I've seen a lot of service messes, though.
I was confused with the number of CRDs I had to write. I was like, oh boy.
Yes.
I will just copy and paste them all.
Yeah, YAML is really good at copy and paste.
True fact, I failed my CKA twice before passing it a third time because I hate spaces. I can't count. I had to use a linter to put periods for me instead. Do not take CKA advice from me. So. We can talk about anything for the next 2 minutes. I always like the mic, like I was saying up front.
Yeah.
Like, I don't get to talk to a crowd this is my first in-person event since 2020.
Cool.
Yeah.
Well, then apparently I'm too close now.
Oh yeah. Actually, you don't have to wear a mask anymore in Delta.
Yeah.
Mid-flight, I saw on my Twitter feed people ripping off their masks. Yeah.
And flight attendants starting to collect them. I'm like, okay, that works.
Please hang my mask in the first class coat rack.
There you go.
Somewhere for like really warm. Like just hang it up, please.
On a really, really small hanger.
Violent.
Or like one of those with all the clothespins on it. So you have one hanger and it's for holding belts or whatever, ties. And you just clip in each mask and then you have all the masks.
I never knew that. I always would fight with them, push the clips aside. How does my shirt fit on this? I learned there's 2 types of hangers now at hotels. Thank you, Rob.
Yeah.
I learned something from this talk today. So.
The cool part about those clips, though, is that oftentimes they're not all that wide. So you can just put your shirt over the top. So, maybe you have your pants clipped in or over the hoop and then the shirt over the top.
Nice.
It works.
Multifaceted talk. I love it.
Yeah.
Life advice. But with that, Rob, I think we're at time. Howdy, friends.
Ooh.
Security. Yeah. I'm the most insecure person here, which is ironic to maybe MC the security track. I'm a walking security violation. But here with me today is my buddy, Rob. He's going to be talking about service mess to service mesh. So, Rob, take it away, friend.
Awesome. Thanks, Robbie. I'm so excited that we get to talk about service mesh today. We're going to look at both Linkerd and Istio today. We're going to look at the pros and cons of service mesh. What is service mesh? And here's the part where I tell you I am definitely going to post the slides on my site tonight. I've followed speakers trying to get them to post their slides, and it hasn't worked out very well for me either. Which is why you can head to robrich.org right now. Let's do that. Let's go to robrich.org. We'll click on presentations here at the top. And here is service mesh to service mesh. The slides are online right now. Achievement unlocked. Woohoo! While we're here on robrich.org, let's flip over to the About Me page and we'll learn about some of the things that I've done recently. Let me refresh that. There we go. I'm a Jetpack developer advocate. If you're struggling with your service mesh, I would love to help. I'm a Microsoft MVP, Microsoft MCT, Docker Captain, friend of Redgate. That's a lot of acronyms. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Atlanta or wherever you're connecting from, then hit me up on Twitter or email, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6, that's a brand new book. That's really fun. I got to work with Sean and Matt on that. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my coveted .NET Rocks mug. So let's dig into service mesh. Remember when you learned how to drive? You remember the fun that you had being able to expand beyond just your neighborhood, farther than your bike could go? You know how freeing it was to be able to get to the next neighborhood, the next town? Let's imagine this small town where we can drive on these roads as fast as we want to, get wherever we want to go really quickly. That's really fun. Well, in time, our little town starts to grow up, and we end up with a traffic jam. I've stared at this picture for a really long time, and I'm like, okay, so if that car moves, and then this car can, and then the bus, I don't know how they got into that position. I know even less of how they got out. But now we have some concerns. How do we get to where we're trying to go? Well, of course, we're going to put the traffic cop at the edge of town. The traffic cop is here to, well, enforce the traffic rules. What he's going to do is he's going to find anyone who's going faster than the limit and make them slow down so that we all go uniformly through our town. Now that's great. We're all getting to our destination. We're no longer stuck in the big mess anymore, but we focused on uniformity, not on excellence or on getting to where we need expeditiously. Really what we want is something like this, where our cars can start to work together to find the best path. Let's prioritize the traffic. Emergency vehicles and those people who want to go really fast definitely can. Those people who want to take a more leisurely pace definitely can as well. Ultimately, now we're getting to our destination in the most efficient and effective way possible. We're not focusing on uniformity, we're focusing on delivering excellence. So let's talk about service mesh. Now we're going to see Istio and Linkerd, which is really fun, but we're also going to talk about why do we need a service mesh? Or conversely, why don't we need a service mesh? So first up, a service mesh. A service mesh manages the network traffic between services in a graceful and scalable way. Or said differently, service mesh is the answer to how do I observe, control, or secure the communication between my microservices? Now that's interesting. Let's look first at observe. I want to be able to watch the traffic flow through my cluster so that I can understand what healthy looks like. What does unhealthy look like? What are the instances in my application where it might be behaving badly? Once I'm able to understand what good looks like, let's also look at controlling that behavior. Should this service be able to talk to that service? Or should we block that traffic? And finally, we can secure it. Let's create a mutual TLS connection. Now, what's interesting about TLS is when we hit a particular website, we can validate that the server is who they say they are. But the server can't necessarily validate that we are who we say we are. With mutual TLS, there's a certificate on both sides, creating a really secure encrypted traffic where both sides can validate their endpoints. Now, creating that in our applications is pretty intense, especially when we need to keep track of trust chains. So on the left, we have a monolith. And on the right, we have microservices. Now, monolith was great in that we could kind of package up all of our things. We could deploy them together. We didn't have to worry about all of the pieces communicating. On the right, we have microservices. Now, what's interesting about microservices is we can redeploy these whenever they change. Containers have made this possible. Deployment is no longer hard. But now each of our internal methods has an IP address. I don't really want you calling my internal methods if I'm not ready for that traffic to come in that way. As we talk about service mesh, we're going to talk about both north-south traffic and east-west traffic. North-south traffic is traffic flowing into our Kubernetes cluster or traffic flowing out of our Kubernetes cluster. By comparison, east-west traffic is traffic flowing between our microservices. Now, the interesting thing is a service mesh can secure both our east-west traffic and our north-south traffic, both ingress and egress. So here's an example of a service mesh. Now, one of the principles of microservices is that it owns its own data. So the way I get at a particular data store is I call the microservice that owns that data store. Now, obviously, in this case, we're not doing that. We've got microservices calling into each other's data stores. We really want to be able to secure that. So we created API Gateway. Now, API Gateway was a great way of being that firewall around our cluster, that fence around our cluster. Now, what's cool about an API Gateway is, like the traffic cop, nobody coming into town too fast is able to get in. Nobody coming in on random ports or with unusual requests is able to get in. But it's only a fence around our cluster. So this traffic between microservices, the API Gateway has no visibility into that. API gateways can be great for billing and for rate limits, but they're really not suited for this securing communication between microservices. So how does the service mesh work? Now, if we don't have a service mesh, we just have service A, and it reaches out to service B, and it communicates. With a service mesh, we have this. We have this Envoy proxy. Now, this Envoy proxy is actually really helpful. The Envoy proxy allows us to proxy traffic between communications. So every container is deployed in a pod, and we might choose to deploy a sidecar proxy here. So service A wants to communicate with service B. Service A is going to reach out to its sidecar proxy. The sidecar proxy is going to reach out to the service mesh control plane. Is service A allowed to connect to service B? And where is service B? In this case, the control plane says yes. So service A's proxy reaches out to service B's proxy. Service B proxy checks in with the control plane again. Am I allowed to accept connections from service A? In this case, the service mesh says yes, and service B forwards that on to service B's proxy forwards it on to service B. As service B replies, it goes through this encrypted tunnel and back to service A. Now, this is the pod boundary, and communication between service A and service B is within that pod, so that's a local network connection. But now we've offloaded that mutual TLS connection from our application into our service mesh. And we have this mechanism of preventing unwanted traffic into our services. This is excellent. Now, what's cool about this is the same mechanism for communicating between ingress and egress. So what if I want to connect my ingress to my service? Well, I go through an ingress proxy. Or what if I want service A to communicate with an external service? Then I'll go through an egress proxy. And that allows me to do mutual TLS across my services and then to be able to reach out to the outside world. So service mesh, observe, control, and secure. What's really elegant is because we are proxying traffic between each of our microservices, we're able to observe all of the communication between our microservices. Now we can start to make decisions. Let's make policies and say, are these containers allowed to connect to these other containers? Now, obviously, we need to work with our developers to ensure that they're not trying to do things that we're about to block. But we can start to shape that traffic to ensure the traffic flows the way we expect. And finally, we've got mutual TLS. If we choose to enable that, then we have secure communication between all of our services. Nothing else running in the cluster is able to snoop on that traffic. So that's excellent. But the cool part about a service mesh is it's not just the proxy. We can start building layers on top of this. So for example, because we're proxying all of the traffic between all of our services, we can create a network topology diagram. Now the beautiful thing here is this network topology diagram is not what the developer thought was going to happen. It's what's actually happening in the cluster. Now we can compare that with the architect's vision and see if we've met their needs, but we can describe the traffic as it's actually happening. We can also create service health things where we can watch a service, identify what healthy is, and see when it fails. Are there too many HTTP 500 errors coming out of a service? Maybe that service is no longer responding in a timely manner. Maybe it's time to restart that service. And we can also start to collect logs of how these services behave. Now, these aren't console logs, these are network logs, but we can say, here's how many requests per hour, here's the percentage of healthy requests. Now, that's really elegant. Because we're proxying the traffic between all of our services, we have this ability to create these. Now, let's level up again. Because we are proxying the traffic between all of our microservices, we can do really interesting things like A/B tests. Let's deploy 2 copies of our service. Let's route traffic to each one and see which one is more performant or has more engagement. and then let's lean into that one. Let's do some more experiments and see if we can continually optimize our process. Similarly, we could create a beta channel. Let's release a new version, but only to our beta customers. And because we have the ability to route traffic between these microservices, we can notice that this is a beta channel customer and route them to the other version, where all the normal traffic goes to the previous version. And similarly, we can create circuit breakers. Now, what's really elegant with a circuit breaker is that if a service becomes unhealthy, it's really easy for us to, well, assume that it was a temporary network glitch and retry the request. So the service is struggling, and we're all retrying. Have you ever had a website load slow and you just hammer the refresh button? Now the web server has a whole lot of requests built up on it, so the moment that it comes back up, it topples over under the weight. Let's flip the circuit breaker open and just block all connections to that service. We'll just hard fail those requests for now. But unlike the circuit breaker in your home where you have to go fetch through the kitchen and go turn it back on, we can watch the service, and once it's healthy, we can come back in and we can reconnect our traffic up to that service. These circuit breakers are really powerful in maintaining healthy services and ensuring the health of our system. We also end up with really cool dashboards, and we're going to dig into the dashboards both in Linkerd and in Istio to be able to highlight how we can monitor this content and how we can envision our system. So our goal is to block that mechanism. These services are communicating in ways that we don't expect, and we don't really want them to do so. So we can observe, control, and secure the traffic in our cluster between our microservices. When we're choosing a service mesh, now there's lots of different service meshes. Istio and Linkerd are the two famous ones. Open Service Mesh is a brand new one that Microsoft built. There's others, Consul, and there's a lot. My goal is not to sell a particular service mesh, but to give you the search terms that you'll need to discover the service mesh that you need. Now, a lot of these are moving really fast. So if we were to do a feature comparison, the answer would likely be different in a minute. So instead, let's compare these not on their features, but on their methodologies. First, Linkerd. Now, Linkerd's methodology is really fast startup time, everything in the box. Linkerd is a great contributor to the Rust networking stack because they need Rust to be able to do this service mesh methodology. Now, they have a proxy, and they're able to do the normal service mesh things with these proxies. They have a control plane. But a lot of the features are built in. If you want to go beyond their normal mechanism, you'll likely need to pull in additional plugins, third-party plugins. By comparison, Istio really likes this kitchen sink approach. They try and group all of the best of open source and have feature flags to be able to enable or disable them. In Istio, we'll see that we can pick a profile that kind of sets some of those feature flags, or we can start to tune them. Do we need this dashboard? Do we need mutual TLS? We can start to turn these things on and off. So where Linkerd wants everything built into the box, Istio wants to be able to combine the best of open source. So let's take a look at these. Now I'm going to start off flipping over to my Linkerd cluster. And let's take a look at the docs getting started with Linkerd. The first thing we need to do is ensure that we have a Kubernetes cluster. Next, we'll go grab the Linkerd CLI, and we can take a look at that. Then we'll do a Linkerd check -- pre, which goes and validates if our cluster is ready. Next, we'll do a Linkerd install, pipe it to kubectl, apply, and that gets us ready to, that gets that content in place. Next, we'll do a Linkerd check. Let's do that. Linkerd check. And Linkerd check will now go through my cluster and validate that all of the services associated with Linkerd are running. The next part is we can go grab some dashboards. So Linkerd viz install, pipe that to kubectl apply, and now we have some dashboards. Linkerd check again, and we can see that we've got all of the content, including all of the Linkerd dashboards here. Here's the Linkerd viz extensions. Okay, so next up, let's take Linkerd for, One of the ways that Linkerd knows when to install the sidecar proxy is that we put an annotation on the namespace. So here I'm describing the default namespace, and we see that Linkerd inject is enabled. That's Linkerd's hook to be able to know that it needs to put in that sidecar proxy with each of the pods that it schedules in this namespace. Next up, let's take a look at the dashboards. So I'm going to say Linkerd viz dashboard, and we'll get to see the dashboards associated with Linkerd. So let's pick a namespace. Let's pick Linkerd in this case. And we can take a look at the pods, the cron jobs, the replica sets, the details associated with this namespace. Now, I want to take a look at some of the Grafana dashboards. This is one of the few tools that they bundle with it. It spits out Prometheus metrics, and I can see the Grafana dashboards associated with this service. Now, that's elegant. We're able to kind of explore our service, but if we want to do this from the console, we can do that as well. So I'm going to say Linkerd viz stat, and I'll give it a particular namespace. So in this case, the Linkerd viz namespace, and I'll take a look at deployments. Now we can see the latency associated with our services, the number of active TCP connections, and the success rate. So it looks like Linkerd hasn't failed me yet. That's excellent. Now we saw how Linkerd really focuses on a really fast launch experience. I just say Linkerd install, pipe that to kubectl apply, Linkerd check, and everything's running. Next up, let's flip over to Istio. So I'll flip over to my Istio cluster, and similar to the way that we get started with Linkerd, we're going to get started with Istio. So we start out downloading the binary. We'll get into that folder, set it in our path. We'll install Istio, and we can see here where we set that profile. Now the profile identifies which feature groups are enabled, but we can definitely tune those to turn on and off the features that we need. In a similar way, we're going to label our namespace as Istio injection enabled. So let's go, not that one, let's go look at our default namespace. And we can see that we've got this Istio injection equals enabled here as well. Now that tells Istio that it needs to launch that sidecar with each pod that is scheduled. So now that we've got Istio installed, the next thing we can do is deploy this sample application. Now this sample application is really cool. Here's the docs for it, where we can take a look at this ingress proxy. It goes to this product page. The product page goes to various review services and to a details service. And the reviews then go reach out to this rating service. Each of these dark bars is that Envoy sidecar proxy. So we can route the traffic between them. So I've got this application launched right here. And we can see that we have different rating stars here. We have 3 different versions running. Now in one version, we don't have any stars. In one version, we have stars in black color. And in one version, we have stars in red color. Now we probably wouldn't run all 3 at the same time, but for the sake of this demo, I've got all 3 enabled right now. Here's the network, the virtual service that allows us to route that traffic to all 3, and that's the one that's running right now. Let's flip it over to just version 1. So let's go copy this one, and we will say kubectl apply. We'll give it this file, and now we're on version 1. Oh, we are not in the correct directory. Samples, book info, networking. That's the folder we need to be in. There we go. So now that we've got version 1 applied, now we're not going to see any reviews, any stars. Okay, so now we want to get ready to start deploying version 2. We've got version 2 packaged, we've built the container, we're ready to start it up, we've got that started up, and now let's start to push traffic to it. Now in this case, I'm going to set 80% of my traffic to my regular service and 20% of the traffic to this new version 2 service. So let's grab this one, and we will kubectl apply this one. Now we're at 80-20 between version 1 and version 2. So I've very specifically turned off sticky sessions. We might want to have sticky sessions so that those that upgrade end up with the new version and stick with it. But in this case, 4 out of 5 times I'll get the lack of stars, and 1 out of 10 times I'll get stars in black color. Excellent. It looks like version 2 is working. So let's flip all the way over to version 2. OK, kubectl apply will go to version 2. And now all of these are completely in black color. Excellent. So now that we've got everything in black color, let's take a look at version 3. Now with version 3, we want to create a beta channel. So those users who are logged in can see version 3, and those who are not can see version 2. So in this case, if the user includes Jason, then we'll hand them version 3. So let's flip over to version 3. Version 3 for beta users. And so now we'll see that because I'm unauthenticated, I'm logged out here, I'm still seeing version 2. Let's log in as Jason. And now I'm seeing version 3. If I log out, I go back to version 2. Great. Our beta channel was a success. We're ready to upgrade completely to version 3. And so let's flip over to version 3. And now we'll see that the stars are completely in red color. Now we just did a rolling update where once we've got the new service installed and we've forwarded traffic over to it, then we can start to kill off the older version. Next, let's take a look at the dashboards that are here inside of Istio. And then I'm going to get pushed off stage. So we've got a Prometheus dashboard. And the cool part about Prometheus is that we can take a look at some metrics. So let's look at Istio requests total. Execute. Now we can see the Prometheus metrics here. That's interesting, but probably we want to be able to visualize these a bit. So let's look at the Grafana dashboard. So now we're taking a look at the Prometheus metrics, but in a really elegant way. So let's come into this dashboard, and we can start to see the health of our system. Now, it hasn't been up all that long, but we can start to look at Istio itself. Istio, like Linkerd, dog foods their things, so they've got sidecar containers into their control plane, and so we can start to take a look around at those services. Next up, let's take a look at not that one. Let's take a look at the Jaeger dashboard. Now, the cool thing about Jaeger is we can start to see traces, where we can take a look at one request calling another. So let's take a look at our product page, and we'll look for traces, and let's look at this one. We can see that this request called this request. This request then called into here and into here. So if we're looking for why is this request so slow, definitely not this one. But then it makes a call to here, which calls this one, which calls this one, which calls this one. We kind of have a flame graph here, and it's nice to be able to visualize the things. Well, it looks like this service is taking a whole long time, so maybe that's where we want to start looking at the cause of our slowness. Next up, let's take a look at the Kiali dashboard. Now, the cool part about the Kiali dashboard is that here's where we can start to visualize the services within our cluster. So let's take a look at graph. We'll flip over to all namespaces. And actually, we probably don't want that one. But we do want longer than 1 minute. So we have our gateway that goes to our product page that goes to version 1 of that service. It goes over to the details of version 1. It also goes over to our reviews service, where we were monkeying between those 3 different services. We had version 1 and version 2 and version 3. Version 2 and 3 go figure out how many stars they should show. Version 1 does not. We can elegantly describe how our system behaves. Now, the beautiful thing is this is what is actually happening in the cluster, not what the developer thought was going to happen. Well, what if we notice that the product page isn't calling the review service at all? Maybe we hard-coded the debug version of it, the mock version, and forgot to undo that. This graph is elegant in being able to describe that to us. This is what is actually happening in the cluster. One of my favorite ones. That's cool. So we saw how we could take a look at Linkerd and Istio. Linkerd focused on a really easy startup and everything baked in the box, where Istio focused on the best of open source. Whichever service mesh you find, you can probably have a great experience. So I'm definitely not suggesting any particular service mesh, but definitely search for a service mesh. Maybe Istio and Linkerd gets you to the one that exactly matches your organization. So as we were starting to look through this, we looked at kind of this crawl, walk, run experience. In our crawl scenario, we have monitoring and logging and service health. Because we're proxying traffic between all of our services, we can take a look at our services and see the communication patterns between them. As we start to walk, we can make intelligent routing decisions. I don't think you ought to be able to call the other service's data store. I think you ought to focus on calling the service instead. Or let's block unauthorized traffic into our billing microservice, because only the shopping cart service should be able to call the billing microservice. And then as we start to run, now we can take a look at a network topology diagram where we can see the traffic that is actually flowing in our cluster, not the traffic that we thought was going to flow. Because we have these sidecar proxies communicating on our behalf, we can start to view all the traffic in our cluster, we can create intelligent routing between them, and we can start to monitor our system. Now, the service mesh is not without its downsides. On the left, we have the standard diagram of Kubernetes. We have worker nodes in blue, we have our control plane in green, and we have the pods running our content. Here on the right, we have the control plane for the service mesh. Now, the service mesh has its own control plane. It has those sidecar proxies. So basically, we're running twice the number of containers in our cluster. Now, granted, the Java monolith in Tomcat is a little bit heavier than the sidecar proxy that just needs to do TLS connections, but it's still doing a lot of TLS math, so it's not without its workloads. So we probably won't have twice the compute cost, but we might have 1.5, a little bit more. So if you're just looking to check the box, understand that you will also pay more for compute to do so. Observe, control, and secure. Now, the cool part is that we can take control of, we can start to view the communication between our microservices, we can start to control that, and we can start to secure it in really elegant ways. If you have these needs, a service mesh is great. If you don't have these needs, if you're just looking to check the box, maybe service mesh isn't a great fit. So here's my best practices. I would say that you should use a service mesh if you're running highly sensitive workloads, a PKI workload or a HIPAA workload, something where you definitely need that to be secure and separate. Or perhaps you're running untrusted workloads alongside your first-party workloads. We want to keep those other workloads separate. Now, in Kubernetes, we do have namespaces, and we like to think of namespaces as divisions. Yes, we do have roles tied to a particular namespace, but those are organizational roles. I can't launch something that's not in my namespace. But once inside my namespace, I can communicate with any other pod running in my namespace by default. Where a service mesh can start to lock those down. Perhaps we can create specific swim lanes for a multi-tenant environment with a service mesh. If we need security in depth, if we need to encrypt the traffic from the client through all of our microservices to that endpoint, then a service mesh might be perfect. And if we need A/B routing or a beta channel, then a service mesh can give us that. But if we don't need these features, then service mesh might be overkill. It's not just the next thing to install in our cluster. There might be some costs associated with that we don't want to take on yet. Get comfortable with your cluster as it is, and when you're ready to ramp up into a more secure or more visible environment, then a service mesh can be really helpful. This has been a lot of fun getting to introduce you to service mesh and walk through Istio and Linkerd. If you're watching this later, hit me up on Twitter at @Rob_Rich, and let's continue the conversation. And for those of us who are here live, I'll be here for the rest of the conference, and let's definitely dig into Q&A. The slides are available online right now at robrich.org. Thanks for coming.
Yeah, Rob.
Do I have time for Q&A?
No.
Is that one already on?
That one's not going to work anymore. They'll cancel each other out if you turn that one on.
Oh, okay.
But
Let
you
me
can.
introduce Brendan really quickly and then.
And then turn it on?
Right. We're almost here. We are at time. The second Brandy turns on her mic, this mic will be turned off. So, really excited to be having a Brandy talk with us today, talking about collaboration, penetration testing, and all sorts of cool stuff. And so, without further ado, Brandy, please take it away.
On. How's everyone today? Hope doing well. Thank you for having me here today. I was actually invited last week, so I put this together very quickly. I saw there were some other discussions about incident response, so I wanted to do something different. So I will be talking about pen testing and DevOps, but security as a whole as well. So I'm the Director of Cybersecurity Operations for Avalon Cyber. We are a managed security service provider, so we do penetration testing, network, web app, mobile app, incident response, and managed detection and response services, as well as advisory services. So we definitely play in the security space, and when working with developers, it's, again, really on the web and mobile app penetration testing side. So my information is up here. Please connect with me on LinkedIn, and looking forward to questions after. I'm going to start with a video that my penetration team put together, so I think it'll be fun. Let's see. And that's why security matters. Thank you. They had a lot of fun doing that. As you all know, technology is tough, but it's who you work with that makes the day count. So big props to them for putting that together. But all of the time we work with developers, I'm sure they're not looking forward to working with us. They've spent a lot of time and put a lot of effort into the apps that they're developing. And here we come and we're just there to do an audit, right? And we find these vulnerabilities, and of course they have to go back to management. And that's never a fun conversation to have, but really collaboration is all about setting the proper expectations up front. We are here, just like in the financial industry, we have to have your checks and balances. That's all it is. And so together, we can get through the security issues. It's a team and collaborative approach. It's definitely not something that we see as trying to hack and prove a point. So we always go in, verify scope. What are we here to do? What are we here to accomplish? Here's the findings, remediations. If you want us to take a look at it again after you apply the remediations, we're happy to do that. And through that exercise, we kind of form a relationship where we're doing this on a set cadence, right? Because that's the point. I'm going to jump into some automation here in a moment, but DevOps, SecDevOps, DevSecOps, nobody cares at this point. If you've been reading the news, last year there was an executive order on improving the nation's cybersecurity, and that has basically propelled NIST Secure Software Development Framework, the SSDF, into the life cycle, right, the SDLC. So what we're talking about is now government agencies are requiring that their software vendors provide attestation that this has been put in place. And if you don't have that, in a matter of time, I think it's next month it's effective, you could be losing business. And so for your management and for your leaders, if you're publicly traded, for your shareholders, that's going to become an issue. So for the developers here today, thinking about security, it's no longer an afterthought. Not that it was, but it really is coming down to a point of you have to do it. And you have to use automation to help you stay creative and to help you get those features in, and to make sure the automation is just part of it from the start. I'm really excited to be here today to see the different tools that you developers use to kind of make sure that happens, so that's really great. I do know, in talking with our developer friends, SAST and DAST and IAST and RASP are all tools that you utilize, right? And some of them have their pros and cons. I know that RASP can kind of be a crutch sometimes for security, which it should not be. It's nice to have, but it's certainly not something that you just need to rely on. This is my first time speaking in like 3 years on stage, so a little bit nervous, but I appreciate being here today. So we talk about automation. Everyone uses buzzwords and, hey, this is all automated, this is AI, this is great. We all know that that's not the truth. It still takes people, process, technology in that order. So you can throw all the tech at it you want, but it doesn't matter if you don't have the people doing the right things and implementing things as you go along. The automated tools alone are just not enough. We need the human element, and we'll never replace that. So going on to, when doing a penetration test, obviously there are multiple ways to complete that: white box, black box, gray box. We typically, go in with a web app assessment. We look at it from an authenticated and unauthenticated perspective. Obviously, when working with clients, you want to look at it pre-production and then post-production, both angles. And so you want to really set up that budget expectation for your business of what's going to be needed. Because obviously, you're doing things throughout the SDLC to improve the security of the app, but you can't do that alone. You need to have your checks and balances, your third party, whether that's internal penetration testing teams that you have put together, that's great. If not, external. And that's really just to ensure the security of the application, because as we saw in the video, what takes you 9 to 12 months to develop can be exploited within a matter of minutes. If you've ever seen a penetration test, you know that it should include the finding, the actual proof of possible exploitation, and thorough remediation guidance to ensure that you can go in there and quickly apply that. A penetration test is the time box assessment. It's a snapshot in time. We all know that. You can set up the automation to constantly run in the web application or mobile application, whatever you're developing throughout it, but just think about these people are in there for a matter of a week or two. So they're looking at it from that perspective. An attacker could have weeks, months. We've worked on several incident response cases where literally they were in there for months, just maintaining their persistence, waiting for the right moment to deploy ransomware or to exfiltrate data. So going back to the executive order, again, I just want to really, have everyone be thinking about this, because that's going to apply to everyone. Even though right now it's just government agencies, if you think about what government agencies use, everyone uses the same stuff, right? So you have to really be thinking about that. And another thing, if you work in the fintech space, if you haven't heard, there's a 36-hour rule now that financial industries have to notify the regulators if they are breached. What does a breach mean? So that's going to be really interesting. So we have all these regulatory things happening in the cybersecurity space that are all kind of starting within the next few months and becoming mandatory. I am a technologist with a law degree, so my first and foremost concern is always legal and compliance. I know some people are like, well, we can't, hinder creativity to meet compliance, but it is an important aspect of software development. And it's certainly going to shake up the software supply chain. I think we're all kind of aware of that at this point. So going back to the automation, I mean, these, I'm not going to tell you guys, the developers, obviously you are using these things. Just encourage it. Whatever tools are available that you can automate that compliance and that security throughout the life cycle, I mean, of course, do that. You don't want to slow down your progress as a developer. So as much automation as you can employ, I would certainly recommend. We've all seen this, OWASP Top 10 Application Security Risks. So from 2017 to 2021, there were 3 new categories added, 4 categories with naming and scoping changes, and some consolidation in the top 10 for 2021. Now, whenever we go in to do a web application penetration test, I mean, we're kind of starting with this list, right, and then going from there. But these are the must checks, because these are the basics that should be in place. You should, have protections against these vulnerabilities that may exist. I just want to bring up, I think the Log4Shell vulnerability took all of us by storm. I know for us on the security side, we had clients reaching out to us like, hey, what do we do? How do we scan this? How do we detect? And specifically in web applications, we're like, scanners are great, but you kind of need to do a pen test. You need to look at this very thoroughly. You need to do a code review. Widely used Java applications leveraging the Apache Log4j, they required immediate patching. And so we were working with a ton of our partners and web app developers and businesses just to try to address this. We use Nessus. We were using that. We were using some open source scanners. CISA, the Cybersecurity Infrastructure Security Agency, released some recommendations. Definitely recommend checking that out. For some organizations, they even offer free assessments. So free security assessments. Definitely recommend going to their page to see how that could help you. But, Log4j is just one kind of, no matter how secure you develop your app, it doesn't matter, because if there's a 0 day, if there's a vulnerability, what are your dependencies? How are you keeping up with that? Do you have a way to go, query on, hey, I just want to see if Log4j or PrimeFace or something is being used somewhere, and say, okay, I know this is vulnerable, let me address it in these 10 applications out of the 50, that we have, that we're supporting. I just remember the nights for weeks and weekends working on the Log4j issue. And I just think it really takes us back to why we need to know what is in these applications, because we cannot control the uncontrollable. We can do as much as we're able to, and we have to be able to jump quickly when things like this happen. I mentioned PrimeFaces. So PrimeFaces 5, we were working with a client, and fortunately they had our EDR protection deployed to their web server, but they kept getting basically attacked, and it kept preventing it. But the web app developer said, well, I can't update PrimeFaces for a while because it'll take down stuff. So their box just kept getting hit, and it kept blocking it. Eventually they applied it. But, and I'll talk at the end here, but that's why you have to have those defense in depth layers. I mean, of course, you can't take everything down, but if you're getting attacked, like a ransomware or data exfiltration is much more difficult to deal with than taking a server down for a while to apply an update. So never, let downtime overshadow security, because seeing and experiencing multiple incident response situations, data breaches, they are very stressful. So going on to the next page, these are just things that we typically see in web apps, right? These are vulnerabilities that we identify during a web app penetration test. And you can see here, unauthenticated API access. I know there was someone who talked about API security. That's a huge deal. I think we all have stories from the trenches. We did a web app once, and we were just doing our thing, assessing, and out of nowhere, we literally came across an unauthenticated API, and we were able to gain access to all of the client data, PII, PHI, everything. At that point, we went from doing a web app security assessment to calling in legal counsel, to considering cyber insurance coverage, to potentially having to notify all of those people. And I don't know if y'all know the process of how that occurs, but we do data breach review stuff. So you literally have to take the impacted server, you have to process it, denist it, dedupe it, apply AI, search terms, and try to get that down to, from 90 gigabytes to a readable set of data for human review to then build entity list to then notify those people. So when you get those letters in the mail that say like, hey, you've been breached, that took a lot of time and a lot of money to get to that letter. So again, the risk of not doing security properly can be very costly to the business and to the, it can cause brand damage. So just thinking about incidents and how we can prevent those in the software development life cycle is making sure that security is a part of that from start to finish. After the product is out there, how are you evaluating it? What is your cadence? Yeah, you do an annual assessment, but again, snapshot in time. A lot changes in between 12 months. So just looking at these vulnerabilities, source code disclosure, there's just some development artifacts, obviously outdated versions, file upload functionality. That's a big one. We had someone receive a ton of malware stuff, and they had no kind of scanning in place, and they were opening up files. Basic stuff that we were like, okay, that's, we can deal with that. But it happens, so just make sure that you're addressing it throughout the year, not just that once a year, because 0 days come out every day. And it's getting worse and worse. And if you don't have a constant, vulnerability scanner running at that endpoint, you're kind of blind to it until something happens. So defense in depth. Let me get my notes here. Sorry, I got out of order. They're back forth. Okay, so defense in depth, we've all heard it. It's truly key in preventing web application, API attacks, host-based attacks, cloud attacks. Again, just going over some of the basic vulnerabilities that we see. You can enable, automation. You can enable multi-factor authentication. You can enable these things, but it doesn't mean that something won't happen. We've seen before where multi-factor authentication was enabled and someone gets an alert on their phone and they just hit accept because they're getting overwhelmed with it, right? So MFA is definitely not a sure bullet. Social engineering, you hear this all the time in security. Users are your weakest link, and that is so true. So really, training users, once someone gains, authenticated access to something, what's going to pick up on that? So what are your access rights? How are you managing, group policies within apps? How, the different roles that you assign? Do they have access to anything that they shouldn't? Obviously, practice least privilege. What logging and alerting do you have in place? What does it log and how long is it stored? Going back to the situation where we had the API issue with the web app, the logs were not being monitored. So the web server logs weren't even being monitored. So they looked back to say, maybe there was any spike. Their retention was like 7 days. So we couldn't even really look back to identify if potentially that data had been accessed over a period of time since a year when the error, when the misconfiguration occurred. So that just goes, again, legal risk. You've got regulatory stuff. If you're depending on you're in the healthcare or fintech space, that could be really big. Passwords. We think about I heard someone say the other day is, as developers, you're trying to do your job, you're trying to get things done, and security team's like, hey, you got to change your password, you got to do this. And whenever NIST changed their recommendations, it was based on the assumption that you are really using long and complex passwords, that you're using a password manager, that you're using multi-factor authentication. And if you're doing all that, great. I agree, every 3-month password changes are ridiculous if you're using a 25-character complex password, MFA, and a password manager. But if you're not doing that, then that's why they have to do the 3-month password policy change. And my penetration testing team would tell you that even if you are doing that, we have cracking rigs. We can crack passwords very quickly. Even if you are doing that, if your password is exposed, MFAs helps, but it's exposed. It's out in the dark web, and we find lots of data on the dark web all the time when we do our investigations. So that's why they still believe, a lot of penetration testers believe in doing the 3-month password policy change, so at least you are rotating those in case for some reason it was exposed at some point. I wanted to, I covered the data breach process review again, point A to point Z. Of what a data breach means and how it can easily occur due to just a misconfiguration. I just think, again, it's just so important to know that it's not just ransomware, it's not just business email compromises, it is small misconfigurations. So, just keep that in mind, and you certainly don't want to be the person who's sitting there like, I'm sorry that this happened, and it's a real big deal. So yeah, no, I think as a whole, I know I didn't hit the whole time, but I just wanted to cover, again, security as a whole, penetration testing, how we work with those DevOps teams, some war stories. Again, I think we all have those and we've experienced some things. But that is my talk, so I appreciate you listening.